Welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 7 from the Mechanics M1 January 2022 International A-Level Edexcel exam paper. And this question is here about a pulley and a string and some connected particles. It says a particle P of mass 4m lies on the surface of a fixed rough inclined plane. So this is a rough plane. The plane is inclined to the horizontal at an angle of alpha, where tan of alpha equals 3/4. Okay. The particle P is attached to one end of a light, inextensible string. The string passes over a small, smooth pulley that is fixed at the top of the plane. The other end of the string is attached to a particle Q of mass m, which lies on a smooth plane. So this side is smooth, and this side is rough. So on this particle P, there will be friction. Particle Q will not have any friction. Okay. The string lies along the horizontal plane and in the vertical plane that contains the pulley and a line of greater slope of the inclined plane. Okay. So the system is released from rest with the string taut, as shown in figure 4, and P moves down the plane. The coefficient of friction between P and the plane is 1/4. So on this side, the coefficient of friction is 1/4. Mu stands for the coefficient of friction. For the motion before Q reaches the pulley, okay, before Q reaches the pulley, so obviously it's going to go down the plane here. Write down an equation of motion for Q. Okay, so P moves down the plane. All right. So now, write down an equation of motion for Q. So a few things to discuss here before we proceed. On this side there's friction, this side there's no friction. Okay, they told us the tan of alpha is 3/4. Now, if the tan of alpha is 3/4, all right, if I make it like a right angle triangle and I call this alpha, and the tan of alpha means the opposite, which is this side over the adjacent. So the tan of this angle would be 3/4. So that would be the opposite, that would be the adjacent. That means the hypotenuse of this right angle triangle would be 5. 3, 4, 5 triangle. The square root of 9 plus 16, the square root of 25 is 5. Which means that the sine of the angle alpha is going to be given by opposite over hypotenuse, which is 3/5. And the cosine of angle alpha is going to be given by adjacent over hypotenuse, which is 4/5. Now that's important for us because when we want to solve problems like this, it's instead of finding what the angle is and then writing the sine of the angle as a decimal, it's much easier normally to deal with them in this way, especially in this type of question. As you'll see in the next parts, they'll ask you to write things in terms of m and g, and it's much easier to deal with fractions rather than these decimals that are rounded. You have exact answers better. All right, so if you think of the sine of the angle as 3/5 and the cosine of the angle 4/5, when we resolve forces, we normally have, like, for example, mg sine alpha. So we can do mg times 3/5. 3/5 mg instead of having some decimal that have to round. So that's something that's important for us to think about. Makes life a bit easier if we just, instead of finding alpha, just find what the sine of alpha is and what the cosine of alpha is, because that's what we're going to use. That's one thing. All right, now the other thing is some people don't understand what it means by the string lies along the horizontal plane and in the vertical plane that contains the pulley and a line of greater slope of the inclined plane. What does that mean? Well, if you were to look at this inclined plane from this angle, you would see, like, for example, a slope. Okay, and there would be a pulley at the top of the slope. And what it means is that this particle is basically not at some sort of angle on the plane. It's straight down the plane. Okay, so it's like the line of greater slope of the plane. So it's basically not at any angle as it's lying on the plane. It's, if you looked at it from this angle, it would be going straight up the plane. Okay, not like at any angle, side to side. That's what that means. Okay, that's one thing. That's something else. And then what else? Okay, that's fine. Let's just go ahead and put what we need up. Just put a diagram here. So they're asking us for the motion before Q reaches a pulley. Write down an equation of motion for Q. Okay, let's just deal with Q then. For Q we have some of the forces acting. We have the weight. Those are the forces acting on Q. Okay, which is mg. You also have the reaction force, which is straight up. The vertical force when two particles are in contact with each other, two surfaces are in contact with each other, sorry, that's the reaction force. And you also have the tension in the string, which is pulling it this way. Okay, that's the tension in the string. And that's the only force acting on it, basically, in this direction. Now it's accelerating in this direction here. Okay, so if I take this side as positive, I can say T is equal to its mass times its acceleration. We don't know what the acceleration is, so that's basically that 1 mark for this question. T equals ma. Simple as that. All right, that's the answer to part A. Very simple. T equals ma. And there's the answer for that part. Now what I'm going to do here, I'm going to draw the other forces as well, because part B asks us to find the tension in the string. So what I'm going to do is I'm going to draw the forces acting on P on this same diagram and use it for part B. So the forces acting on particle P are its weight, which is straight down. Okay, so this is 4 mg. And you have the reaction force between the surfaces, which acts perpendicular to the surface, which is, I'll call it R for now. You have the tension in the string. Okay, that's the tension. Now this is accelerating down. So we also have, because this is a rough plane, we have the friction, the force of friction acting, which is actually reached its maximum value, F max. Now we also have, well, those are the forces acting, but what I want to do, I want to resolve the forces in the direction of motion and perpendicular to the direction of motion. Okay, so parallel to the direction of motion and perpendicular to the direction of motion. So I'm going to, this angle is alpha. Okay, this angle is alpha here, same as that angle, because these two triangles are similar triangles. This triangle and this big triangle are similar. So this angle here is the same as that angle. So if I resolve this 4mg perpendicular to the plane, you have to resolve this going into the angle. So this is going to be 4mg times cosine of alpha. And if you resolve this force parallel to the plane, well, this will be 4mg times the sine of alpha. That's parallel to the plane. Okay, so now I've resolved these forces parallel and perpendicular to the plane, and it's this force diagram now is ready for me to answer part B of the question, which I'll show on the next page. Okay, so it says find in terms of mng the tension in the string. So we've got to find the value of the tension in the string. All right, this is some of the information we got from the question. We know the value of the tan of alpha, therefore the sine and the cosine of alpha. We also know that the coefficient of friction is 1/4. Now, the tension in the string, we also know from the first equation that the tension in the string is equal to ma, because of the forces acting on particle Q. Now for P is going down the plane in this direction. So I'm going to resolve the forces parallel to the plane. So we have 4mg times sine alpha. That's acting in this direction. And what's opposing that motion is the tension in the string and also the friction, because this side has got a rough plane. Okay, and that's equal to the mass, which is 4m, times the acceleration, which we're going to call a. Okay, so now, if I resolve the forces perpendicular to the plane, I'll be able to help us find what F max is, because we know that F max is equal to mu times R. So what we can do is we can say that the reaction force here is equal to the component of this perpendicular to the plane, which is equal to 4mg cosine alpha. All right, so now from this I can say that R is equal to 4 times mg times, now the cosine of alpha, as we stated before, is 4/5. So that's 4/5. So that gives us 16 mg/5. So therefore we can say that F max is equal to mu times R, which is 1/4, as we were told mu is 1/4. quarter times 16 mg over 5, which gives you, that cancels with that gives you 4 mg over 5. That's F max. So F max is equal to 4 mg over 5. All right, now, so let's now use that in this equation here. So we have 4 mg times the sine of alpha. Now the sine of alpha is 3/5 minus the tension, which we have to find, minus F max, which is 4 mg over 5. I'll just show that we're using that same equation, is equal to 4 times ma. Now we know that the tension is equal to ma. We know that T is equal to ma. So that means that ma, I can replace it with T. So this is equal to 4 times T. Okay, so that's now an equation with just T in it, and we can now find what T is. So we got, this is going to be 12 mg over 5 minus 4 mg over 5 equals 4T plus T, which is 5T. So this gives us 8 mg over 5 equals 5 times T. Therefore T is equal to, if I divide both sides by 5, 8 mg over 25. So that is the tension in the string. Okay, 8 mg over 25 newtons. That's fine in terms of m and g, the tension of the string. So that's, you want to leave it in this form in terms of m and g. Okay, so there's the answer to part B of this question. Okay, so T equals 8 mg over 25. Now we're going to go on to part C. Okay, now for part C, it says find the magnitude of the force exerted on the pulley by the string. Okay, now we know that because this is a light string and this is a smooth pulley, that the tension on either side of the pulley is going to be the same. Okay, the tension on either side of the pulley is going to be the same because this is frictionless pulley and the string is light. Okay, and the string is light. Okay, so the tension on both sides of the string will be the same in each section here. So now what I can do here is I can set up an equation. I know that I've just concentrated on just the section of the pulley in the diagram. So I've got here, let me just use that without the arrow. Okay, so I've got here this section. All right, just we know that this angle here is alpha. That's alpha, right? That's what from our diagram before. And this is a right angle here. Okay, so what I can do is this. I can make a force. So there's different ways of doing this. I'm going to do this first by making some sort of a force diagram. Okay, so I'll basically draw one of the forces. So let me draw this force first. Okay, so I'll draw this force. In fact, I'll just use a line without an arrow. So I'll draw this force first. And then where this force ends, I'll draw the force going in this direction. Okay, so like this. But they're the same length because this is T and this is also T acting in this direction. So the resultant force is going to be the force acting like this. Okay, this is the resultant force. Let's say that's the resultant force. That's TR. Okay, so this is an isosceles triangle. All right, and I know that this angle over here, we can see it's going to be the same as the angle. If I continue these, it's going to be the same as this angle over here. It's alpha. It's the angle between those two forces. It's going to be basically alpha. So this is angle alpha. So to find the resultant force, let me call it FR. That's the resultant force. To find the resultant force, I can actually use the cosine rule here, because this is, I know these two lengths, I know the angle, I know the cosine of the angle, 4/5. So I can say that the resultant force here is going to be the square root of, if you use the cosine rule, b squared plus c squared, which is t squared plus another t squared, minus 2 times t, 2 times BC, so B and C are both T, so it's 2 times T squared again, times the cosine of alpha. So that should give me my value, and I know that T is 8 mg over 25. I'll leave it in terms of this first, and then fill in the T later just to make life easier. So this is going to be the square root of, I have this is 2T squared minus 2T squared times cosine alpha. Okay, again, to make life a bit easier, in terms of manipulating this, I can write this as the square root of, now this is going to give me, let me write this as 2t squared and 1 minus cosine alpha. Okay, and now let's just put everything in. So I have the square root of 2 times, now t squared. Now we know the t is 8 mg over 25. So this is 8 mg over 25. That has to be squared. And that's times 1 minus cosine alpha, which is 1 minus 4/5. Okay. Now 1 minus 4/5 is going to be 1/5. So I have the resultant force is equal to, that's 2 times 64. That's going to be mg all squared. I'm going to square it at the end in the end anyway. Over 25 squared, which is 625, times 1 minus 4/5 is 1 over 5. Okay, so let's just simplify that. That's going to be 128 times mg all squared over 5 times 625. I'm going to find the square root of that. So let me just use a calculator. So I'll put the square root of 128 over 5 times 625. Okay, let's see what that gives us. Gives us 0.2. Can I make that a bit simpler? Let's try to do this without using decimals. Let's try and give it an exact value. We can write this as 2 times 64. 2 times 64. And I know some of the square roots here, so this is going to be the square root of 64 is 8, so there'll be 8 times root 2 times mg over, and I have root 5 times 25. Okay, 5 times 625. So that's going to be the square root of 5 is root 5, and the square root of 625 is 25, because that was 25 squared, right? Okay, so now let me simplify this. We have 8 root 2 over 25 root 5 mg. If we simplify that, we can multiply both top and bottom by root 5. That gives me 8 times root 10 over 25 times 5, which is, I think, 125. 25 times 5. Yep. So that's going to be 8 root 10 over 125 mg newtons. So that's going to be the resultant force. Okay, so we can say the resultant force is equal to 8 root 10 over 125 mg newtons. And there's the answer for that question. Okay, so that's one way of doing this question. Okay, that's one way of doing it. There's also other ways of doing it. For example, what we could have done is we could have actually found what this angle is, and we could have said that the resultant is going to be exactly halfway between those two. So I could have found what the whole angle is, divided by 2, and then I could have said t times cosine alpha plus t times cosine, not alpha, t times cosine of this angle plus t times cosine of that angle will give me the answer. So I could have done that. I could have found what this whole angle is. And this whole angle, we could have found it by doing 90 plus this angle, which is basically 90 minus that angle. So we could have done that. Okay, and so this we could say that this angle here, let's see if we can, I'll just show you how to do it this way as well. That's a nice easy way in some cases. So let's see here. So I know that this angle here is 90 minus alpha, and I know this angle here is not this angle, I know this angle here from there to there is 90 minus alpha, and I know this angle here is 90. So the total of these two angles together, so this whole angle from, let me do it in a different color, the whole angle from here to here that whole angle is going to be 90 plus 90 minus alpha, which is 180 minus alpha. That's the whole angle here. Okay, so what we're going to have, if you want to find the resultant force, I can say that the angle between this force and the resultant, this angle here, is going to be 180 minus alpha divided by 2. Okay, that's this angle here, right? So what I'm going to have is t times the cosine of 180 minus alpha over 2 for this side, and plus t times the cosine of 180 minus alpha over 2. So you'll have 2 times cosine of 180 minus alpha over 2. So in this particular case, it might be a bit more difficult for us to use it in exact form, because we got to, you know, rearrange this, or we can't really do that. So we can find the angle alpha. Okay, we can find what the angle alpha is and see if we get the same answer. So let's see if that works. I'll just show you that, see if it works. I think the way that we did it makes it easy to give us an exact value. This one we won't be able to get the exact value, I don't think, that easily. But let's say inverse tan of 3/4. Let's see what inverse tan of 3/4. That gives us the angle. That's this angle. So we have 180 minus this angle. So 180 minus our angle, and then divided by 2. Okay, that gives us 71.56. So I want to find the cosine of this. So I'll find the cosine of my answer. Okay. And then I want to multiply that by 2 times t. Okay, so that's 2 times, and I'm going to have 8 mg. 2 times 8. So I'll just leave the 8. I'll leave the 8. I'll leave the mg out of this. I'll put 2 times 8 over 25. Oh, it's 25. And that gives us 0.202, which, if you remember, that was exactly what we found earlier. So this is going to give us 0.202 mg. Okay, now let's see if that's the same as what we found. Okay, let's see if that gives us the same answer. In fact, I should still have that somewhere in here. Actually, I didn't write it out fully, so let me write it out like this. So you have 8 times the square root of 10 divided by 125. Okay, let me see if that gives, yeah, it gives us exactly the same value. So this is also another way we can do it. Okay, but it's a bit difficult in this case to give it in exact form, but I don't think that's actually required. Okay, you can leave it in this form. It doesn't say in exact form, so it's fine. I think if you wrote the answer as 0.202 mg, or even 0.20 mg, 2 decimal places, or if you wrote the answer like this, it's fine. I prefer exact values, but both of them are perfectly fine. Okay, so that's 2 alternative ways you can answer this question. We can also do this by resolving forces horizontally and vertically. Okay, that's also possible. But I'll just show you these 2 ways. Now, part D. State where in your working you have used information that the string is light. Now, this question is only worth 1 mark, but if you read the examiner's report, it mentions that very few people got this question correct. And that's because of some kind of, misconception or misunderstanding or incomplete understanding about tension in strings. So basically, we know that on both sides of this string, the tension is going to be the same. Okay, and how is it that your string being light is, how does that make the tension the same? Okay, that's something that a lot of students don't quite understand. Okay, now basically what we used is we stated that the tension on both sides of the pulley is the same. Okay, that's what we used in order for us to get the answer. Now, most people would say that we ignored the mass of the string. Okay, that's how we used the fact that the string is light. All right. So in the working, we didn't consider the mass of the string. Okay. Now that's not actually 100% true. Okay. That's not in our working where we can show that. Okay. What we used is the fact that the tension on both sides of the string is the same. Okay, that's what we used. And how is it that the string being light, contributes to this? And the reason that contributes to this is because if the string had mass, okay, then the tension would be different in different parts of the string. So the tension in this part of the string and the tension at this end of the string would be different. Okay, because if it had mass, then for this string to be taut, on this part of the string, it has to pull not only, okay, on the pulley, it also has to pull the other parts of the string that are before it, and the tension on this side of the string would only be pulling on the pulley. Okay, it won't be pulling on the other sections of the string which have a mass, and therefore, it will cause the string to have to pull all those parts of the string, okay, before it. All right. So the tension is the same in each section of the string, okay, when the string is light. Okay, so that's why the tension is the same on both ends of the string here, and both ends of the string here, the tension is the same. So what we can say is we have used the information that the string is light, okay, by assuming that the tension, so we can say the tension is the same throughout. Now you don't say just throughout the whole string, but you say throughout each section of the string. Each section of the string. Okay, so this end and this end, the tension is going to be the same. Okay, so the tension here and the tension here will be the same. Now in the examiner's report, the word section is very important. If you just say the tension is the same throughout the string, you don't get the mark. You have to say throughout each section of the string. Okay, so that's something important for you to mention in this answer. Okay, so there's the answer to part D of this question. Part C and D of this question. Other questions from this paper can be found in the playlist that should appear in this area over here. Other questions from this particular topic, which is to do with connected particles, can be found in this playlist over here, and you can subscribe to my channel by clicking on this link. On the top of the page you'll see a card which takes you to some other paper you might want to watch. Thank you for watching, and see you soon.